and that is 2. All right, so hopefully you're in here for the Ansible and Drupal presentation. If you're not, there's other presentations going on. I know I wanted to go to the Silex one, and I'm sure that that's where half the other people that could have come here are. But thank you for coming to mine. I am Jeff Geerling, and I currently am a technical architect at Acquia. I also own Midwestern Mac LLC. You might see some blog posts from there on Drupal Planet. And mostly I'm a developer, but I do a lot of ops work, mostly outside of Acquia, mostly for Midwestern Mac and other projects. And I'm also writing a book. I'm the author of Ansible for DevOps. I've actually been writing it for a year, and it's been published for a year. I started off publishing just the first few chapters, and as I've been writing it, I've been publishing as I go, which is awesome. You can read more about that on the server check-in blog. But it's on LeanPub, and for everybody here, it's 50% off. Also, I wanted to note that all these slides are online, so if you're having trouble seeing them, I know this projector's not the best in the world. If you're having trouble seeing them, go to MidCamp or the joined in talk page, and there's a link to the slides so you can actually see them. It's nice to be able to read things when they're on the screen. So first I wanted to start with a few of the problems that we're trying to solve. I know a lot of people here might be already using something for configuration management, might be using something for deploying things or managing your infrastructure, but the problems I see most often with Drupal is your infrastructure is growing. It used to be one server somewhere and one production server somewhere, and you deploy straight to there. Nowadays, you might have a production server and a staging server, or you might have 10 production servers and 10 staging servers, and then 17 other servers for dev, UAT, testing, all these other environments, and a bunch of local environments. That's a lot of servers to manage, and there's no way you can scale manual processes to all that. You can. I've seen people do it, but it's very disgusting. Drupal deployments are more complicated today, too. In the old days, it was you dragged a module up or you did something like that, and then you ran stuff on prod. Now you're moving features between environments. In Drupal 8, you're moving staging, or you're moving configuration, and you're deploying that. You're running database update scripts. You're running grunt tasks. You're running all these different things to build your site. And a lot of times, you're even doing things like building a new container and then deploying your container all over the place. We need tools to help with that. And finally, one of the things that I see a lot nowadays is you're doing more deployments. You know, in the past, it was you deploy every quarter, or you deploy every 6 months, or some organizations like once every 10 years. Now you're deploying every week, every 2 weeks, every day, every hour. Some cases every 10, 20 minutes. Whenever somebody pushes a commit and it passes tests, why aren't we putting that on production? If your development workflow can support it, you need tools that can support it too, to be able to deploy quickly. You might also have problems like local development environments. Why does something work in Solar 3.6.5 on this guy's machine, and then we've deployed to production with 3.6.6, and boom, it all fails? Or if you're doing geospatial search, everybody has to have the right version of everything, Drupal, Solar, the whole chain, Java, to make sure that those kind of features work. So we need to solve that problem. We need to be able to clone our production infrastructure. So not only for things like a blue-green deployment where you have 6 servers, you need to set up 6 new servers, deploy Drupal to it, and then switch to it. You need a tool to help with that. Luckily for you, we have that tool, and it's Ansible. Ansible is, I call it configuration management for humans. There are a lot of tools out there that do things like Ansible does. Some of them are not built for humans. They're built for programmers, which are slightly human. I'm one of those. But Ansible really dumbs it down to a point that you can approach it quickly and then do whatever you need to do in a way that is decipherable and easy to pick up. Most people that I've introduced to Ansible say that they've learned it in an hour, 2 hours. They were already deploying to DigitalOcean or Amazon or something within an hour or so. You can't do that with some of the other tools that are out there. It uses, and one of the reasons for that is that it uses SSH, which is how everybody does server management with Linux everywhere. It also does things for Windows, but I'm not going to go into that. SSH, if you can connect to your server through SSH, you can use Ansible. Don't have to install things, don't have to have dependencies on your servers running all these different things. Some other tools have ways of doing that, sort of, or you could use tools like Func or something to push out different commands to your servers, things, but Ansible is built from the ground up that way. Everything is built to be asynchronous, deployable to all your servers without having to install anything on your servers or having to manage. Basically, you don't have to have a configuration management tool to manage your configuration management tool, which is great. I like that. And it has, Ansible is built with a batteries included philosophy. A lot of times with some other tools, you have to download it, download 25 different other things, and then run some commands to get those other things to work with your thing. That's not how Ansible is built. Everything is built in, and it's very easy to extend. It has basically JSON is its API. So if you want to write a PHP script, if you want to write Python, Go, Node, whatever language you want to use, you can use it to integrate with Ansible. All you have to do is pass out some JSON and take back some JSON and process it. There's also roles on Ansible Galaxy, over 3,000 at this point, that configure pretty much anything you can imagine, anything from Apache, MySQL, to more exotic new web servers and exotic new tools and things. Basically, community contributed roles that are all available on GitHub, all open source, and save you hours of time in building your own configuration management scripts and setup. And there's a lot of great examples out there too for if you want to build your own role to do something like configure Apache. There's a dozen examples to build from. So it's easy to install as well. The only thing that Ansible requires is Python on your system, and I don't think I've had a computer in the past like 5 or 6 years that didn't. So on a Mac, you can use Homebrew. If you are a Python developer, which anybody here do a lot of Python? Probably not. Okay, good. Well, not necessarily good, but I mean, this is a PHP Drupal thing. So you can also install it using yum or apt. And if you have Windows, you can install Linux and get some real work done. So let's get started. As I said, it takes an hour or so to pick up, less or more. Ansible really has 3 main things. There's a lot more to it, but these are the 3 main things that you'll use in your day-to-day usage. And with these, if you know a little bit about these 3 things, you can pretty much do anything. All of Midwestern Mac's infrastructure is built with a simple inventory, some playbooks, and then things like mitigating heartbleed are done with some ad hoc commands whenever you need to run something quickly and get your servers in a state that you need them to be in. So inventory is like a hosts file. It's just you tell your servers, you tell Ansible, these are my servers. And then Ansible can use that to run commands on them and do things on them. Ad hoc commands are, it's basically like logging into your server and running a command by typing it in. But Ansible makes that more powerful because you can run the servers on batches, or you can run the commands on batches of servers. I'll show you how that works. And then playbooks are Ansible's way to make your infrastructure in code. So you can kind of codify how do you build this server and then save that to a file, and it's really easy to do. And I'll show you that too. So at the end of this presentation, my goal is to have Drupal 8 running on that cluster of Raspberry Pis, and I've nicknamed it the Dramble. The reason I did that is, and don't look up Dramble right now, because if you do, you'll see that it's something about like somebody that's high walking around stumbling after they've been high. That's not what the Dramble is. It's the Drupal Bramble. A Bramble is a cluster of Raspberry Pis, so it's the Dramble. Anyway, I could have chosen a better word, but whatever. But please don't take any flash photography. These are Raspberry Pi Model 2s, and Raspberry Pi 2 Model Bs. Their naming is crazy. And they have a little chip in them that if you take a flash picture, they'll all shut down. So please don't do that. It'll take a little while to reboot. But the cluster itself has about 5.4 gigahertz of processing power in aggregate. I could have overclocked them, but when you're doing live demos, you don't want to do anything that can cause instability. It has 6 gigs of RAM, 96 gigs of micro SD card space, and it's using SanDisk Extreme cards, which are way, way faster than most of the cheaper cards out there. So it's decent, but it's still like 20 times slower than an old spinning hard drive. And it has a 1000 LAN with a gigabit backbone connected to my MacBook Pro through a gigabit USB 3 adapter. So that is our data center. We have 6 servers. If my budget allowed, I would get like 90 servers, but my budget doesn't allow, so we got 6. They also have LEDs on the front. You can see they're green right now. That means they're happy. They're ready to go. And those are all wired into the GPIOs on the Raspberry Pis, so I can remote control, change the colors on them. They're RGB LEDs. So pretty fun. I had a lot of fun building it. That's a nice close-up picture. When you build something like this, you have to take pictures and do stuff. So anyway, that's our goal. Our goal is to get Drupal 8 running on that stack. I thought it was a lot more fun to do it with Raspberry Pis than on a bunch of VMs, because VMs are very wishy-washy. Where are they? They're in the cloud, whatever. This is hardware. This is a lot more fun. Plus, I got to get out my soldering iron. I haven't done that since I started having kids. So let us begin. First, we want to describe our servers to Ansible. So we have 6 servers there, and we have some IP addresses that might be mapped through DNS server or whatever. In this case, I have 3 web servers. Those are the 2nd, 3rd, and 4th from the top. So in our inventory file, we can have a group. So in this case, web servers, and then we have the list of the servers. That's an inventory file. That's all there is to it. You can define other things in here too, but for our purposes, we just want to tell Ansible, we have these 3 web servers, and they're called web servers. That's it. So once you do that, we have this little inventory file, and I saved it in etc Ansible hosts. You can start running commands on them. So this command uses the Ansible command to run a simple command or module on the servers. So in this case, we're using an Ansible module called ping, one of the 270 built-in modules. It's a very nice module for pinging your servers. So here's how that looks. If we type in that command, I just did this last night, and to save myself a few seconds, I recorded a GIF, and here it is. Pretty simple. It takes a couple seconds to do the initial connection to the servers, but once it does, it shows you Pong. So it says it can connect to these 3 servers. That's great. Now we can build the world. So let's have a little more fun with this, though. We're going to take a look at these RGB LEDs and how we can control them, and also we'll see how quickly Ansible can communicate with these servers. So here begins the live demo portion, which I've rehearsed a few times, but last night I found out everything can go wrong. So hopefully that doesn't happen.
Don't flash.
For the benefit of the people on the stream, somebody just tried taking a flash picture. Everybody tackled him. All right. So right now the LEDs are green. I want to switch them to blue, so I'll just run the command Ansible all. All just is a shortcut to do every server in your inventory. All right. So I ran this command, and now the LEDs are blue. It's amazing. So you saw that it took a few seconds. That was the initial connection. Ansible uses connection pipelining and some other cool tricks to make SSH really, really fast. Almost as fast as some of the very specialized protocols, which were custom written by some of the other configuration management tools. But anyway, it runs this command to switch the LEDs to blue, and the command is Ansible, and then I use the shortcut all for all the servers, and then I give it an argument, and if you don't give it a module, so usually you give it a module, like ping. If you don't give it one, it just runs the command as if you were typing it on the server. And the command is RGB, which is a script I have to control those LEDs, and it gives it a color, blue. And then -s says run it as sudo, because on the Raspberry Pi you have to run it as root to control hardware. So anyway, it runs that command. So to demonstrate, though, how Ansible connects to them, it did that all instantly. At least it looked instantly. Once it got that connection, we can actually say forks equals 1, and what this is going to do is tell Ansible, run it on one server at a time before you finish and go to the next one. Oh, and I'm turning them blue again, so that's not going to be really that helpful. So let me run it and switch to red so that you can actually see what's happening. So there's 3, and you can see this is very slow. In the old days, this is how people manage servers. Isn't that crazy? They'd log into a server and run a command. Yeah?
So by default, how many parallel commands are going to go out?
Ansible defaults to 5 forks, so it'd do 5 servers at a time for each command. But you can control that in your configuration or on the command line here with forks. But if I go to forks equals 2, and I just did red again, let me go to green again. So if I do 2 at a time, you can see it's doing 2, 2, 2. I think that, yeah. And then if I do something like 6, it should do it all instantly. So I'll go back to blue, and it's instant. Pretty much instant. I mean, it took like half a second. Yeah?
Are you going to show the setup time as far as like your SSH key management?
We can talk about that towards the end, because that does involve, that's a little complex, but generally you're going to have to do that no matter what kind of tools you're using. But we can talk about that at the end. Let's see. So, and you can also say, I want to just limit this. Let's see. So I have one cache server. The Redis server is the second one up from the bottom, and I just turned it blue. I need to turn it red. So you can say limit it to one of the servers in the group. So in this case, did it turn red? Okay, I can't see because of the projector. And anybody who's slightly OCD in the audience right now might be cringing. So I'll turn them back to a nice, pretty Drupal blue for you. So I have another one that lets me give RGB values. And so now it should be a nice, it's kind of a Drupal blue. It's hard to reproduce Drupal blue on an RGB LED, I found.
Yeah.
Required a lot of tweaking. So we'll pop back into the presentation. So that's how you control RGB LEDs on the Pi, and that was probably like 6 hours of my life that I spent just setting up that little part. But it's so cool. I love it. So let me switch back to the presentation. Alrighty, shiny. That's to sum up those 6 hours. All right. So we can see how ad hoc commands are nice. You can run a command on a bunch of servers. I didn't go into the hundreds of different ways you can make that even more cool and efficient and awesome for if you're managing 6,000 servers. There's a lot of people using Ansible that have hundreds or thousands of servers, and you can do these things fast. It's pretty awesome. But you can run commands like sudo apt-get install PHP 5 common. You want to put PHP on your servers, go ahead and do that. It'll install it. But that doesn't give you a lot. That's just like you logging into each server or using some sort of tool to do the logins and have a bunch of windows on your screen, which I see people still do a lot these days. They have like 25 windows for all their servers, and they run a command and it copies it to all of them. That's about the same. It doesn't give us much. So Ansible has modules. We saw one earlier, the ping module, and we use the command module to run commands. This is the apt module. And for all of Ansible's modules, you just give it the name of the module, and then you give it some arguments. So in this case, a name for a package, which is PHP 5 common. And then you give it a state, saying, I want it installed, I want the latest version, I want it absent, I want it gone. And then Ansible will do whatever it takes behind the scenes to make that happen. And then if you run the command again, if you run this once and it installs it, then run it again, the second time it'll just say, hey, it's already installed, no problem, that's it. So it gives you a little bit more insight into what's happening on your servers. So that's a better way. But the best way to configure a server is to use a playbook, because you're codifying everything that you do in your playbook. And this helps you solve the problem of snowflake servers. Here's a very beautiful little picture of a snowflake. Even if you are using infrastructure as code everywhere and all your stuff is perfect and beautiful, you probably still have a server somewhere that you know by name or you know where it is. That's a problem. Netflix has said many times in their infrastructure engineering group that you should treat your servers as cattle, not as pets. You should never know a server by name. If you know a server by name, that's a problem. You need to fix that server, get it in code, and make it so that if that server went down right now, you could have it back up again within a couple minutes by redeploying it. Or you have like 6 hot spares, and you just don't care about one particular server. Even if it's a build server or whatever, those servers should all be in code. Now, for most people, that's a pipe dream. It's going to take a while to get there, but Ansible gives you a good first step towards that. So Ansible playbooks make your infrastructure in code, and all it is YAML. So the presentation that was in this room before this talked about configuration management, and he mentioned that Drupal 8's using YAML. That's awesome because YAML is a configuration language for humans. That's basically the only purpose. Languages like Ruby and Java and all these other languages, they're programming languages. They're not designed for managing configuration. So when you try, like in PHP, we put tons of configuration into the big arrays of doom. And that's overloading that language feature. So we don't want to use a programming language to configure things. It doesn't make that much sense. So Ansible chose to use YAML. SaltStack uses YAML too, so no hate for SaltStack. No hate for anybody here, but I like the fact that my configuration management tool can be approachable by anybody on my development team and my ops team, and heck, my wife or whoever else wants to jump into it. They can see, oh, so this is what it's doing. They don't have to know a programming language or some strange DSL just to understand how to set up a server. And you run them with Ansible Playbook. That's the command. So we used Ansible to run commands on servers. Ansible Playbook runs playbooks on servers. So this is that last command that we had. It's actually in a playbook, and heck, this playbook actually can run. So if you copy this down, paste it, you'll end up with PHP 5 running on your Debian or Ubuntu specific servers, since it's using the apt module. But basically, at the top of a playbook file, you tell it what hosts it needs to run on, and then you can give it some other options, like in this case, we want it to run all the commands in the playbook using sudo. It's best practice not to run playbooks as root or do pretty much anything as root. And also, if you can, try to break it up so that your playbooks only use sudo when necessary. And then you give it a list of tasks. And in this case, I'm also giving a name for this task. And the reason I do that is because it's self-documenting. So when you're writing the playbook, you might stub it out by just saying, install PHP, install MySQL, configure PHP, configure MySQL, and then you can work on each of those tasks separately. And then when you run it, Ansible shows you in the command line, which I'll show you in a bit, it just shows you that name, so you know exactly what's going on. So it's all self-documenting, simple to read, simple to pick up. And this is one way to format it. You can do other things with YAML to make it look different. But this is a basic playbook, and you could do this and install MySQL, and heck, you'd have your little own, you'd probably need Apache or Nginx or something too. Then you'd have your own little LAMP server in Ansible and like 12 lines of YAML. So there are some other features in playbooks. We probably won't have too much time to talk about them today, but there's include, so it's kind of like PHP include. You just include a playbook in another playbook so you can break up your code a little better. There are variables that are very flexible, so you can have host-level variables, group-level variables, dynamically built variables, variables built on other information. You can do pretty much anything you need to get a variable from your servers or put a variable on your servers. Also, Ansible uses Jinja 2 for its templating syntax. Jinja 2 is actually the ancestor to Twig. When they were making Twig, which is used in Drupal 8, which we know and love, the designers behind Twig looked to Jinja 2 basically as their guide. So it uses double handlebars as printing a variable, and it uses filters and things like that. It's a very simple way to do templating. And finally, Ansible has roles, which I talked a tiny bit about. We'll get into it a tiny bit more probably. But basically, you can take chunks of configuration, package them up in a nice little folder, and then either share them with the community or just use them internally. But it's ways of, it's kind of like a PHP class or library. You can put together things that go together, and then you can compose your server with those things, which in this case are roles. But back to the dramble. So we want to get Drupal 8 running on this cluster, and it looks like I have about 30 minutes to do it. And Drupal 8 is not known as a speed demon yet, so we need to keep moving. So this is the architecture for what we want to have. There are various reasons I chose this, and come talk to me after this is over. I have tons of data to back up these reasons. So first we're going to have a load balancer and reverse proxy, just one server since I only have 6 servers, don't have too much to spare. So we have a load balancer at the front, and it's going to distribute the requests coming in from the internet to the 3 web servers, and it's also going to cache content that can be cached. And Drupal 8 caching is so much better than Drupal 7. Just an FYI out there. And then we have these web servers, and in this case we have 3. I had a long debate internally over whether I should have 4 web servers since Drupal kills PHP on the CPU. But I just chose 3. It uses Nginx as the web server with PHP FPM, and then I needed a way to synchronize the file systems just for the files folders so that Drupal 8 can run. Drupal 8 is now dependent on having a place for compiled Twig files to run, otherwise you're going to get white screens of death. So I chose Gluster. There's also a ton of other ways that you could do this. A simple way is using an NFS mounted share, but then it's not It's not as redundant. In this case, if one of the web servers goes down, I have 2 more replicated copies of all the files, so that's pretty cool. So it has those 3 things running on it. And then we have the database and cache layer. In this case, I'm using Redis. I also tested memcache. Neither of them make a difference over each other, but both of them give a 15% immediate boost to pretty much everything in Drupal 8, so it's a good idea to use that. And then there's MySQL that we all know and love and hate. So that's the architecture, and this is one of the playbooks. This is not like a look at this, but it's actually this. This is the playbook that sets up the database server. So it's using those roles. The roles obviously have a little bit more to them, but it's a simple way. Like, you can look at this playbook. Like, I could show this to any ops person in the world, and they could say, oh, so it looks like you're configuring a firewall that's going to open some ports, and then you're installing MySQL, and you're installing Munin. And Munin is used for monitoring the servers. I don't have it running because it kills the CPU as well. The Raspberry Pi is very limited. If you've never used one, you'll find out, even with the brand new ones, you can kill them very easily by running any task. And then there's also a role that controls the LEDs. So that is actually the entire playbook that I'm using to set up the database server. The other ones are similar for the web servers, the cache server, and the balancer. And unfortunately, due to time constraints and the fact that I've learned many, many times, never ever demo anything that relies on the internet at a conference. There won't be a live demo, but we can talk about it if we get some time, or in the hallway, or whatever. But we will demo live, and this is when I start shaking a little bit, deploying Drupal 8 to these Raspberry Pis. For those of you who weren't in here, last night I ran through the entire presentation, and when I got to this point, nothing worked all of a sudden. And I found out eventually that it was because there was a 1-second time difference on the Pis, since I don't have a real-time clock on them. So Gluster was messing up, and then Drupal was getting angry and throwing all these exceptions about Twig not being available. But we sorted it out. It's all good. It should work, right? So let us switch back over. Let me hide this. And let's switch back over to our trusty terminal. So I have this playbook. I'm going to kick it off now, and we can talk about it while it's running. Its name is main.yaml, so inspiring. So I'm going to kick that off. It's going to run on the web servers, and when it starts running, it's going to first has to connect. Then it's going to set a red LED on the server it's deploying to. Now, I did this way using it serially, so it deploys on one, then the other, just to demonstrate the fact that you can do deployments in many different ways. I could deploy to all 3 at once, I could deploy it to 1, deploy to 2 at once, and then the other 2 if there were 4. And then you can tell Ansible, if there's a failure on more than X% of these servers, stop, send out a notification, there's an emergency, we need to fix it. So you can do things like that with Ansible. If you just have one server, obviously that's not that helpful, but still, Ansible lets you do pretty much any deployment style that you're doing today. You can continue doing it with Ansible, but all automated. So it's going to install Drupal. That takes like 3 or 4 minutes on the Raspberry Pi 2, and it's not just because the Raspberry Pi 2 is slow. Drupal 8 is still not really that fast, plus when you're talking about like 4,000 files on a micro SD card, things get slow. So while it's doing that, please, if they all turn green on me, just let me know and we'll continue on. But anyway, you see the things it's doing up here. It's first it indicates Ansible is deploying, it switches the LED to red. Then it does some checks, and then it makes sure that some files and folders are existing, makes sure permissions are right, and Drupal always complains and fails if there's one little flag somewhere that's wrong. So it's doing a few things like that. And then it runs the install Drupal task, which I'll show you. So here's the playbook for the web servers for the Drupal deployment. And this is a little longer just because it's doing a lot more. So there was that first command running RGB red to turn it red on that Pi. And then it's doing a check to see if Drupal's installed. It's checking for a little file flag. Then it runs some deployment tasks. It pulls Drupal through a Git repository that's actually running on the balancer. I had it on GitHub, but again, don't rely on conference Wi-Fi, especially when you have to buy a Wi-Fi chip for each Pi. It's no fun. Oh, that one's green. Okay, when all 3 are green, let me know. So then it's going to do some file setup, which, as I said, Drupal hates it when there's one little flag that's off anywhere, and it will fail the install, and Drush will complain. Not a fun thing. So then it does the install, and I'll show you that playbook. This is just an included list of tasks, so this is using an include. and it's running drush si with some variables that we pass in through our variable files. So it runs drush si, that takes forever, and it looks like it's already finished on the second server, so we'll have to switch back to that soon. And then it runs some other commands, so it sets a configuration parameter to make sure that the site UUID is set up right, and then it saves a file saying, hey, the installation's complete, so that next time we run it, it'll pick that up and not try to install again, because that's never good. But when we run it again, it will know that the installation is completed, so it's actually going to run this update script, and I'll show you that in a second after everything's done. It also sets up a cron job, and oh, it's done? All right. So it sets up this cron job, which is nice. The Ansible has a built-in cron module. You can set cron jobs per user, that kind of thing. Pretty spiffy. And then it also says, hey, we're finished deploying, turn it green, and as you can see, all three are green. So I should, this is what was showing before the presentation began, because Drupal was not present. And I should see Drupal now. A minimal Drupal 8 installation of beta 7. And again, the Raspberry Pis are not that fast, so it takes a few seconds, and there it is. So Drupal 8 is now running on this infrastructure. Right now it's using MySQL and the balancer and the web servers, but it's not using Redis because this is a minimal install, just core, doesn't have Redis installed. And if I refresh the page a couple times, it's going to distribute the requests among the servers, and to prove that, I'll swap back over here, and I will show you. Let's see. So here I'm going to request the page with no cache equals true, telling Nginx, don't cache this request, just pass it through the backends. And you'll see here's a request to the www2, 3, 1. And if you look really closely at the front of the Pis, there's a CPU indicator light, and you can see when I send these requests, one of the Pis lights up a little bit, and the next one lights up a little bit. So you can see, that's the other reason I like the Pis. I can see on the hardware what's actually happening in the software. Pretty spiffy. But this site is not that good. I talked to the developers who are working on this Dramble site, and they're not proud of it. And the designers they say it's atrocious. I mean, it's bare bones, but isn't that, it's minimalism, you know? But they said they wanted to make it a little nicer. So they spent a lot of time, in this case probably about 10 minutes, building it out a little bit, making a beautiful new front page. And we're going to deploy that by simply running the exact same command with the same playbook, but giving it a new version using extra vars. And I could define this a lot of different ways, but I'm just going to do it at the command line for convenience. So we're going to say Drupal version 1.1.1. And it's going to take a little time, but I'll show you how it, instead of installing, it's going to skip those steps since it knows it already installed it. So it checked out the updated version, and then it skips all the installation. Now it's going to run our update script, which I'll show you over here, update.yaml. So right now it's doing the database updates. This is pretty quick because there might be a couple for whatever new modules are enabled, but that's about it. And then, let's see, where is it right now? So it's still doing that. And then it's going to use config import, which uses Drupal 8's beautiful new configuration API, which is very rough around the edges, but is actually already way better in my mind than features ever could be, just by the fact that it's built in and does everything it needs to do. It's going to use config import. That takes absolutely forever, so we can talk a little bit about this while it's doing it. And then it's going to rebuild caches. And for anybody that hasn't, who here has installed and played around with Drupal 8 yet? So a few people. Who hasn't? Okay, so we have a half and half. If you do Drupal 7, you know that the answer to it's not working is, have you run Drupal's or drush cc all about 10 times and then tried again? A lot of times it just works. In Drupal 8, you'll be running drush cr. That's the new cc. It rebuilds all the caches in Drupal. So anyway, yeah, right now it's importing staging configuration. So the other thing that's happening in here is I have this notify command, and I also have when. So this is a simple task to run a command on the server, and it runs the command. This little thing is just a YAML language syntax thing to let me do it on multiple lines so I can show you on the screen without it breaking over. But anyway, you give it a command, and then you can say, you can use change dir to change into a particular directory. You don't have to do that. I could just run this command from the right path and everything in it, but it's simpler to do this. And then I also have a when. This is conditional to say, only run this command on the first web server in the web servers group. And we're not going to get into all the nitty-gritty on this, but my book explains everything, so buy my book. Ansible's documentation is actually excellent too, and if you're just getting started, just pop over there and look at their Getting Started guide. And then finally, for each of these, I have a notify option, and then I give it a couple things to do. This tells Ansible, once this runs, if it changes anything, if it reports that any changes happened, then do these things. So in this case, if there's a change, we want to restart Redis, which, as I told you, isn't running, so I'll say how we handle that. And also purge the reverse proxy cache. We want to make sure that when we're deploying an update, it's going to purge that cache so that site visitors can immediately start seeing the new content. So it's still red, that's good. Well, it's not good that it's so slow. But come to the sprints tomorrow, work on Drupal 8 performance. So I'll show you those things. Those are called handlers, what you do when you notify another task. And handlers are just tasks that run when you notify them from other tasks. It's a convenience in Ansible. And the handlers are included in this playbook in handlers/main.yaml, so I'll show you that. So here's restart Redis. And we're using a couple interesting features of Ansible here. We can delegate this to all of our cache servers. So in this case, we just have one, but if we had 20 cache servers, we can say delegate to all the cache servers, and then it will run this command, or in this case, it's going to restart a service using the service module that's built into Ansible. And like I said, this is nice because if you use the service module, then Ansible does all the grunt work of figuring out, like, is this running with upstart? Is this running with initv? How is this running? And then it says, okay, so here's how to restart it. And then once it's restarted, it says, did it actually restart? If it did, it says, okay, it restarted. And if it didn't, it shows a failure. So you let Ansible handle all that stuff instead of typing a command like service something restart, and then it fails when you upgrade to CentOS 7 or something like that, or Red Hat 7. You work with Red Hat, so I have to.
Well, actually, we're switching to CentOS.
Okay, so never mind. CentOS 7. We'll keep with that. So anyway, these are handlers. This is restarting Redis. And then we tell it to do it on all the cache servers, in this case one, but only do it when this variable, Drupal Redis enabled, is true. So somewhere in our vars files, we have set that Drupal Redis enabled false. So by default, Redis is not turned on. I'll show you in a minute how we do that, and it looks like the servers are ready. So let me pop back over here and make sure. Yeah, it looks like it did everything it needed to do. And if I switch back to the browser, our Dramble developers will be so proud of this beautiful new website, which will again still take a few seconds to load because Drupal has to rebuild its caches. And there it is. How beautiful. Who's ever seen something this wonderful? And since it's Drupal 8, it's also responsive. So look at that. Anyway, and it even has links. Links are amazing. That's what makes the web work. So I also wanted to show how the reverse proxy is working. Nginx and Varnish and other tools can do this where it caches your content locally on the balancer server, basically, and speeds things up dramatically. It's kind of like using the Boost module, if you've used that. It stores an HTML file to load instead of loading Drupal and bootstrapping Drupal. But it's a lot more configurable, and I like Nginx because it can be my web server, my caching server, my balancer, and it does a great job at all three of those things. Can't do quite as much as Varnish for certain specific use cases, but for this case, it's great. So let's first use WRK, which is kind of like Apache Bench, but easier to reproduce the results and make sure that they're closer. Apache Bench has weird jitter issues that I've seen. So I'm going to load the page for 10 seconds as fast as I can, uncached. So we're hitting the Drupal servers, and you can see immediately those three guys, they're like, stop. PHP is using 100% of the CPU because Drupal 8 is a little bit heavier on the CPU front. And we're getting 9.5 requests per second. I'm going to run it again just to have a little better data. Whenever you do a benchmark, run it at least 3 times, and then run it like 6 more times, because otherwise you're going to have weird network issues with multi-server. So there you have it, 12 requests per second. So since that was so wildly crazy, let's run it again, see what we get. And this is with 3 4-core servers with a gigaram each, and Drupal's putting out about 12 requests per second, uncached. So now let's take a look at what happens if we visit the site cached. And I'm actually going to up the connection count because the balancer can handle it. So if I do that, this is all hitting the balancer server, and I think you can see the little CPU light is bright on there because it's basically just pumping data through as fast as it can. We went from 12 requests per second to 2,212 requests per second just by serving the cached page. So whether you're using Varnish or Nginx or whatever, you're going to get that same speed up. And in this case, the limitation is the Raspberry Pi's Lambjack. That's 11 megabytes per second is literally as fast as that Pi can push data out. But the cool thing is, that's enough for almost every site I've ever worked on in Drupal. So you could literally run this little Pi cluster somewhere, and if you have mostly anonymous traffic, you could serve up a large volume Drupal website. You can get 2,200 full page requests per second. Pretty nice. But we also want to install Redis really quick. So let me kick that off. I'm just going to say, we saw that variable earlier, Drupal Redis enabled, and we're going to set it to true now. Now I could change this variable in the files, and if you were doing version control for your infrastructure, that's the better way to do it. That way you have a history of what your configuration was. In this case, for the presentation, I just want to do it quickly on the command line. So that'll take a few seconds. While it's doing that, any initial questions? We'll have a little more time before we wrap up completely. Yeah?
During the installation process, are you able to remove a node from the load balancer?
Yes, and I didn't do that in this case just because I ran out of time, but Nginx actually has a mechanism where you can say, take this out of the balance, and in Ansible, you'd use a pre-task for that. So where I say indicate that it's deploying, where it changes that LED, I would also say, like, take this out of Nginx, and then when it finishes, put it back in. That way, your infrastructure remains up while you're doing a deployment. So it can still be serving the requests from the other servers. Now, that brings up a question in Drupal. When we do a deployment, we run database updates, and that locks out the database because you can't have authenticated requests coming through and all that. That's a discussion for another session. There are ways to get around that, but it's not fun. And the closest I've gotten is serving uncached requests, or serving cached requests, keep doing that, but there will always be like a minute or a second or something where authenticated users are not going to be able to get the full experience on your Drupal site, unfortunately. All right, so we have Redis running now. So to prove that, we'll do benchmarks because data is better than speculation. So first of all, I'll pop back over here and make sure we're still running. And if I say, and I also want to prove this is actually a Drupal site, so let's go ahead and log in. I think it just put user 1. So I'll go ahead, and if you look closely, the Redis server should start lighting up a little bit because it's actually building the caches on there. And I'll log in. Someday it will log in. There it is. So this is actually Drupal 8. I'm not, no smoke and mirrors here. And you can see it's running Nginx 1.6 and MySQL 5.5, PHP 5.4. These are some of the faults with the Raspberry Pi Raspbian installation, the packages that they include. And then if I switch back over here, let's get some hard data. So if I run the cached request, it's going to be the same because, as I said, Nginx just pumps out as much as it can. So let's run the uncached benchmark again. And the first time it might be low because it's actually building the caches on the other servers after restarting PHP. So yeah, it's 12, but we can improve that now that the caches are all built. This should go up. I've found in all my benchmarking that almost everything is 15% faster, pretty much everything across the board in Drupal 8, just by using Redis. And so we're already at 14-ish, well, 13.5. being precise. And for some reason, every time I've run this on Drupal beta 5, beta 6, beta 7, this keeps getting slower. I don't know why. I think people are doing things and building new architectures without considering performance, which is okay, as long as we consider performance sometime. All right, so it's getting appreciably higher numbers, so that's good. So we have our full infrastructure now running. It's pumping out Drupal as fast as it can. It's serving cached visitors super fast. That is great. And let us get back to our presentation. And I'll go through a couple more slides, and we have a couple more minutes to talk. So those are the commands we used. Like I said, it's probably better to put those variables in your playbooks or find some other way of managing your variables so that they're version controlled. That way you can bring your infrastructure back to a certain point in time very easily. If you're using containers or something like that, you can also do it that way. And I don't have time today to go into it, but I could do another few presentations on Docker and Drupal, Docker and Ansible, LXC and Ansible. Pretty cool stuff that you can do now. And we ended up with this beautiful version 1.1.1 of our Drupal 8 website with links to make it work on the modern web and link people together, hypertext. It's amazing. And we found that this was last night's result. And for some reason, whenever you do a live demo, it's slower. I don't know, whatever. Maybe it's the buzz in the room or something. But anyway, we have 2,000 requests per second, 15-ish requests per second logged in, or not logged in, but uncached. Pretty decent. I actually ran the exact same playbook here that I have, which required only like 2 or 3 tweaks due to IP addresses. I ran it on DigitalOcean, Amazon, a set of Vagrant managed VMs on my local machine. DigitalOcean was the fastest. It got about 22 requests per second. My local machine got 19 requests per second, and Amazon got like 12 requests per second. So anyway, the cool thing is that these playbooks are all meant to be flexible like that. They can run on any server. I could switch to CentOS, and with a couple small exceptions for Debian-specific tooling that I built in, this would work on a CentOS server, this exact same playbook. No changes required. Because I built the roles to be flexible to say, if you're on a Red Hat server, install this thing. If you're on Debian, install this. It's cool to be able to do that, because you can test then which distribution is the fastest, which infrastructure is the fastest. Am I getting the value out of Linode or DigitalOcean or SoftLayer or whatever cloud provider you're using? Am I getting value out of that? Or am I just paying a ton of money for not the actual fastest servers? So getting this data is awesome. And one other takeaway I have from this is that Drupal 8 is a lot more scalable than 7. There's a lot of functionality that helps with that, built in with caching, with front-end caching, with back-end caching, and with multi-server deployment, but it's not very fast. I actually installed Drupal 7 on the same cluster and got 76 uncached requests per second. That's a pretty dramatic slowdown, but I have to caveat that with saying that Drupal 8 is in a very early beta, and has had very little performance optimization, and that's why we're having a sprint tomorrow. So please come and help make it faster. I know I've already submitted a couple issues based on the Pi cluster that I built, that I found, since these are so much slower than a normal computer, some of the pain points that some people would never see because they're running it on an i7 processor on their laptop. I saw some of those issues, and it's cool to be able to see that. Another reason I like the fact that I built this infrastructure. So submit patches, submit issues when you find them. And also, there's tons more information. Like I said, I spent like 6 hours on the LEDs. I spent like 8 hours on the software, getting it to work correctly and all that. I've been putting everything I've learned into the wiki on the Raspberry Pi Dramble site on GitHub. So if you have any improvements or any questions or anything, just go there, file an issue. And it has a lot of D8 performance and discovery on there. I'm going to wrap that up into a blog post as well at some point when I someday get time. And also there's tons more to Ansible. For 50 minutes, we couldn't go through too much. But if I had like 3 or 4 days, we could get through about 10% of what I want to go through. There's strong integration with Docker and LXC and other container management solutions already built in, again, to Ansible. You don't have to download extra stuff. You don't have to install extra software. This is in Ansible. If you install it, you have it. Ansible Tower is a UI for Ansible so that you can have your business people deploy to new servers or set up new servers. straight from a dashboard that integrates with LDAP so you can have your organization do things. It also gives you real-time feedback on infrastructure management. So when you kick off a job, it's kind of like Jenkins, but for your entire infrastructure. And it actually integrates with Jenkins and Travis and all these other things. Ansible works out of the box with Amazon Web Services, DigitalOcean, Rackspace, SoftLayer, Linode. There are 10 or 20 other ones too. And not out of the box, but very easily, you can get it to work with Acquia Cloud and Platform.sh. Because basically, at its core, Ansible runs your commands on servers. You can write your own modules if you need to. You can do whatever you need to, but like I said, for almost all my stuff, I've never had to do anything like write an Ansible module or do anything special or know one line of Python. I learned Python separately because I was building a Flask app for another Raspberry Pi project, but I've never done Python programming in my life. Don't have to know it. It also does notifications to Slack, email, IRC, any tool that you want to use. HipChat, this is all built in. You can do rolling updates, which I showed a little bit of with one server at a time, but you could do deployments where you deploy to 10 servers, put them into your load balancer, monitor how they're doing. If they're bad, take them back out of your load balancer, revert them, and then put them back in. That kind of stuff. It's a little more complicated just because you have to think about it that way. But Ansible makes that stuff simple because it's all built in the ways to handle that kind of stuff. Ansible Vault lets you manage your passwords and secrets using the Ansible Vault tool so that way you can have your API keys and your passwords and things securely stored and encrypted. And there's tons more. My book gets into some of it, but even my book, it's like up to 300 pages, and I still have at least 15 chapters that I have in my notes. Like, I want to do these, but that'll be for either some other book or I'll just keep writing as I go forever and ever. But and then it'll always be like 99% done. So here's some resources in the slide deck. You can get the links to all these. And the bottom two links, that is my book, and that is the Raspberry Pi Dramble project. And all the code, all the playbooks are on GitHub. So if you want to build your own Pi cluster, I actually have the parts list. It was $402 for every single part that's up here. But you can actually do it a lot cheaper if you buy less quality products. And you might have to buy a network crimper if you don't have one already. But anyway, so all that is on there. And finally, it looks like I'm 2 minutes over my time, but oh well. Hopefully it was worth it. Please leave feedback on the presentation. I'd love to hear it too, especially if you see anything that you wanted to learn more about. If there was a part in it where I was saying something, you're like, oh, I'd love to hear, oh, he just skipped over that completely. Let me know, because I hope to be giving a similar presentation at DrupalCon, and I'm hoping that for your benefit and for everyone's benefit, it has all the information you want to know in a 50-minute compressed time spot. So again, there's the coupon. I also tweeted it, and it's in the slide deck if you want to get Ansible for DevOps for half off. If you don't want to get it for half off, I'll take your money, but that's for 50% off. I'm hoping it's a useful book for you. 1,500 other people said it was so far, so that's pretty. And if you buy it and you don't like it, if you're like somebody who loves Ruby with a passion and you absolutely hate the fact that you're not using Ruby to manage your configuration, then there's a 45-day, no questions asked refund policy. I love LeanPub. If you're considering writing something, LeanPub is an awesome platform for it. But they care about their readers and they care about their authors. So it's $10, and then if you want to return it. No skin off my back. That's it. You can clap. Is the next session at 4 o'clock? 4:10?
4:30.
Oh.
There's a break.
Okay, well, I mean, I'll stick around if anybody wants to talk. You can come up here and ask questions.
Break is actually at 4, so I think we got a few minutes.
Oh, okay, well, hey, I thought I had 50, so. Well, any questions? I'll keep talking to the microphone so people can benefit from it later, but yeah.
So, in a real world example, do you also use it to actually deploy Drupal with like checking out new things, run .cr and stuff?
Yeah, I manage, through Midwestern Mac, I manage hostedApacheSolar.com, servercheckin.com, MidwesternMac.com, and Midwestern Mac actually has a multi-site that runs about 20 different client sites that I run. And I have logged into the servers a couple times, and there were some really weird things happening. But I never log into the servers for deployments. So I have everything managed through Ansible Playbooks. And when Drupageddon happened, that was actually pretty cool for me because like the week before I finished moving my last server into using Ansible, and for the fix for that, I just made a simple playbook that updated bash, or not Drupal, which was Heartbleed. I updated bash and then confirmed it was updated, and then that was it. And then I just said Ansible playbook, run the playbook, and it did it on all like 40 something of the servers in about 2 or 3 minutes. That was it.
Do you use your whole playbook all the time to deploy, or do you have specific
No,
ones? To just
actually discussed that on the wiki because if I would have run the whole provisioning playbook, it takes about 7 or 8 minutes to run, and in a presentation where you have 50 minutes, that's like half your presentation. So I split up the playbook to run the provisioning first, so it installs MySQL, installs Nginx and all that. So that's one playbook, and then at the end of that playbook, I include the Drupal deployment playbook that I just ran here. So the first time I run it, it sets everything up, installs Drupal, makes sure it's all up to date, and then it's finished. The second time, I just run the Drupal playbook, and that way it's a little quicker. Technically speaking, if you're doing continuous integration, it's better to run everything all the time. But for a presentation, definitely not going to do that. But even like if you just need a playbook to deploy Drupal to your test servers or something, it takes like 3 minutes if you do it this way, as opposed to 10 to do everything. It's up to you. Yeah.
How do you get your hardware from bare metal to Ansible way?
Yeah, so that's a good question too. The question is how to get your hardware. So in this case, I had 6 Raspberry Pis. How do you get that from bare metal to Ansible ready, basically? And that's a question that anyone that's run a platform as a service or a hosting company has had to deal with very much in the flesh, because that's the problem. So there's a lot of different solutions for that. Ansible doesn't tackle that specifically, but there are some other tools that you can use. You can use something like OpenStack to manage your infrastructure. That's getting really complicated. But in my case, what I did here, I have another project on GitHub called Diet Raspbian. And what I did for that is, since the Raspberry Pi requires an ARM distribution of Linux, and Raspbian is the most well-supported one, I downloaded the official image from raspberrypi.org, and then I installed it on one Pi, and then I ran an Ansible playbook that's included in that project to put my SSH keys into it, which are specific for this project, just the public keys. And then it also removes some packages that are unnecessary. Like I don't need, is it Wolfram Alpha that comes with the Pi that's like 2 gigs? It's like I have like a 16 gig SD card. Don't waste the whole thing with that. So I uninstall some of the software I don't need. I clean up some files, and I also put the IP addresses and MAC addresses in place so that the Pis can communicate with each other. So that's how I did it here. And I just have a public key that is put on that image. And then I put each one of the micro SD cards, after I clone them on my Mac, into each one of the Pis. And then I run a separate playbook that finishes the networking configuration for the Pis, since each one needs its own unique host name. So that's how I did it in this case. There are a lot better ways to do it if you're doing it a lot. In this case, since it was a one-off, I'll probably reset everything for the next presentation. But since it's not that frequent, that's fast enough for me. Yeah.
Any advice on bringing an existing server into Ansible and capturing that configuration?
Yeah, so that's what I did for Midwestern Mac. I have those 2 main services that I'm running. They've been in basically maintenance mode, but I still make sure they're running well. So I have those 2 services. Each one has a dozen or so servers each. And then I also had a bunch of other servers, like a Git server and a build server and a logging server using Elasticsearch, and the Elk stack, and then all these different things, which some of them I had configured by hand. So the key is, how do I get those into Ansible? And, like I think the Git server, I built it like 6 years ago or 5 years ago, and it was still running to this day. That was actually I think on Linode or something. But I basically just did, it's kind of like when you come into a Drupal site the first time ever. You have to do a code audit, you do a server audit, like what are the services running, what needs to be running, because I found out there's like 12 other services, like what is this doing here? It's just wasting cycles. And then I looked in Etsy and looked at all the configuration files, etc, Etsy. I looked at the config files, tried to find which ones were necessary for the service. I copied that out into a big just folder of all the files, And then I went through and made sure that anything that I had tweaked from the original distribution setting was captured. I just made a spreadsheet and said these are the things I need to configure. Then I just built a brand new server from scratch with that. And then I built it on either on a local VM in Vagrant, or sometimes I'd build one in DigitalOcean. Just it's the same speed either way for me, so either way. And then I would test. I would copy over my data, like in this case the Git repositories. I copied them straight across, and then I ran my tests, changing the Git remote to make sure that it worked on the new server. Once that was done, I just shut down the old server after I had a backup, moved to the new server, and then it was in code. So that's how I do it. I mean, there's still a lot of organizations. I don't know if I'd say most, but a lot of organizations don't have much configuration management in use. So you're going to have to do that. That's the painful part. If you have these snowflakes, you need to analyze the snowflake. You need to look at every little blade of that snowflake and say, this one bends at a 90-degree angle. That's hard. It takes time. But once you do it, the next time Drupal comes around, you run a command, then you say update, and then it does it on all 24 servers or on your, I mean, even if it's your one server, if it's all in code, it's a lot quicker and easier. Yeah.
So then, are your configuration files handled always from a Git repository, or could you also handle that through your playbooks?
Either way. So in this case, I actually managed the settings.php for Drupal in the playbook. Because in this case, I wanted to be able to turn on and off Redis, and I found a fun thing about Drupal 8's caching system and the way that the Redis module, which is not even in an alpha release yet, that was a very, very dev release, you had to set a couple special values in settings.php that would break if they were set before Redis was actually installed and enabled. So in this case, I managed that file inside of Ansible with some variables. I'll show you that actually really quick, because I didn't show you a template. Templates are cool. So let me go and show you settings.php. So this is the settings.php we all know and love. But you'll notice a few things. So here we have these wonderful little handlebars. Let me mirror this. There, now you can actually see this. So it's our settings.php file. We all know and love it. And the database name is actually an Ansible variable that's passed in. And then when we put this settings.php, so let me pop over to deploy. So here's that task. So we use the template module, and we give it a source. So in this case, it's settings.php.j2. That says it's a Jinja2 file. We get a destination. You can set owner, group, permissions, all that kind of stuff. And then also, we want to restart the web server once this is copied over. In case Drupal changes some stuff, we need to make sure that the configuration is reloaded. And actually, I probably should be restarting PHP. I don't know why I'm restarting the web server. Whatever. So version 2.0. And then you can also do things like use group variables. So the host is the first database server in this case. I have one master and one database server. That's probably the weakest part of this entire infrastructure. I usually would have two database servers, a master and slave, for anything important. Or you can make arguments for master-master or certain other kinds of replication. And then there's also down here the Redis. So I have a variable saying if this is enabled, and this, again, this is Twig basically. It's Jinja2, but Jinja2 and Twig are basically like twin brothers, twin sisters, whatever you want. And so I just say if this variable is true, then also print this line. If you print this line without Redis being enabled, then your site will die a fiery death, and you'll have a beautiful white screen. So that's how I manage that file in this project. But for every project, it's going to be different. You know, usually I like managing settings.php in my config management instead of inside of the Git repository, mostly because there's tons of settings in there that are private. Right. So I don't want that to be in my development repositories. Yeah, you'd want to Git ignore it in there so that people can have their own local version, or you could have like a server version and then have an include that has passwords and whatever.
Things like Nginx. It's like you did quite a bit with Nginx, so I'm sure configuration was a lot, or if you wanted to modify.
Yeah. Yeah. So those I have. Hold on, MidCamp. Those I have in here too. So this is the entire project. This is up on GitHub, so you can take a look at it later. And feel free to leave if you need to. We're just talking. This is up on GitHub, and for the web servers, I actually have a couple templates. So here's the www config file for PHP FPM. So I wanted to set this because of the fact that the Pis have 4 CPUs. The max children of 7 was after I did some benchmarking. Again, if you're going to make a change, do some benchmarks, see if the change helps. I set max children to like 2, 3, 4, 5, 6, 7, 8, 9. 7 was the sweet spot for getting the most requests per second without making the CPUs start using too much memory and killing the servers. So this was that file, and I don't know why I used a template for this. I could just say this is a file. But if I wanted to make these, I think my idea was that I was going to make this configurable, but I never did, whatever. To do that, you just say like max children, So that's that file, and then also for Nginx, this file is a template for the server block configuring the server. So you can see when you have a micro SD cards are abysmally slow, especially the cheaper ones. There was one that did 4 bytes per second, not kilobytes per second, 4 bytes per second random write. And I accidentally had that one in the database server first, and I was doing the Drupal install, and I was like, there's no way this will ever work. It took like 25 minutes to do the install, and no, it was like 45 minutes, and I was like, well, too bad I bought all these servers. I can't do a presentation like this. But then I found out I had put that cheap no-name one in there. I put in the SanDisk Extreme one, and it took like 3 minutes or whatever today. What's that? Oh yeah, try running a test server with simple test. That'd probably be about 6 weeks to a month, or 6 weeks to 6 months or something. But for the Pis, I turned off the access log completely because there's no way you can write to the SD cards and have much speed. And also, it was interesting. There are certain gzip settings that actually would be slower because the CPUs on the Pi are slower than a CPU on one of the, like a DigitalOcean server or something. I'm not endorsing DigitalOcean, by the way. It's just I use them mostly because of the fact that I like their setup. But I also like all the cloud providers too, like Acquia. So anyway, but yeah, this is that file. And also, let's see. There's nothing else too special in here, but you can. All this code is up on GitHub. So if you want to run through it, you can actually. There's a script inside of setup. I think it's inside of setup. No, maybe it's testing. So you can actually run this playbook on a set of Vagrant VMs that it'll build for you using this Vagrant file. And it'll set up a load balancer, 3 web servers, a cache server, and database server, all out of the box. And then you can run these benchmarks locally, see how your computer compares against 6 Raspberry Pis. You can also run it on DigitalOcean. I didn't save off the Amazon one because I was running through it and kind of hacking it together. But heck, if you want to do it, send me a pull request, I'll accept it. But this is how you provision servers on DigitalOcean. I set it up so I give it a name and a group, and then it does everything for me. It sets it as a 1 gig instance with Debian in the NYC2 data center. And it's okay that you know my public SSH key, because if you want to put it on your servers, I'll go log in and check out what's on your servers.
Extra processing power.
Yeah, exactly. Bitcoin mining. So anyway, yeah, that's that. Any other questions? I think we're coming up on overtime, so. All right. Well, thanks.